All right, so the next part of the question is from the progressive waves. Part B is from the progressive waves, and I think the next one is the one after this one is from stationary waves. So just let me zoom it in. So in the first part, we need to find the wavelength of the wave. So wavelength of the wave needs to be found out. Make sure you have the calculator. I'll be writing the expression and you'll probably need to calculate. So we need to find the wavelength. We can take the help from the graph, and we know that the distance from the point P to the point Q is given. It is 0.48, but from here back to the trough, that makes one complete wave. But we have some extra part of the wave, which is from here till here. So in the length of 0.48, how many wave cycles do we have? We have 1.5. Now we need to find the wavelength. So what should be the length for one wave? So in 0.48 we have 1.5 waves. What should be the length of one wave? That needs to be found out. 0.32, thank you. 0.32 meters, which means that the distance from trough to the next consecutive trough is 0.32. That's the wavelength. Okay, let's move on to the next one. We need to calculate the speed of the wave. All right, I'll write down the formula for the speed of the wave. Speed of the wave equals to f lambda. Let's find out the frequency, or if we have anything related to the frequency given in the question. No, we don't have. Matter of fact, we have the period of the wave, which is 0.020 second. So I can use the same expression with different variables. I can improvise the formula. We also have this frequency equals to 1 over t. So 0.32 divided by 0.020. Let me know what do we get for this one. Okay, 16 meter per second. All right, then the next one is determine the phase difference between the points Q and R. Okay, so point Q, where is the point Q anyway? This is a point Q and this is a point R. We need to find the phase difference between these 2 points. I mean, for this one, you don't even need to use a formula to find the phase difference, although we know the formula that for a progressive wave, we have this formula to find the phase difference from the distance graph delta D divided by lambda times 360. Let's start counting the phase. This point is at the phase 0, so the phase of Q is 0. I'll simply find the phase of R mathematically and we'll subtract these two. So 0, and this angle is, the phase at this point is 90 180. What do we have then? 270, 360, or you can once again consider it 0 and then 90 again. All right, let's move on to the next one. Figure shows the position. All right, we'll discuss this one later with, and we will link this topic, this part of the question, with this slide. This one. We'll go through this slide once again, and only then we'll discuss that question. Let us take a look at this one. Describe the conditions required for two waves to be able to form stationary waves. So just be writing in the bullets. The two waves must be of same nature. If one of the wave is a sound wave, the other wave has to be a sound wave. If one of the wave is a mechanical wave, for example, it could be a wave in a string, then the other wave has to be a wave in the string. Same nature. Same frequency, speed, or wavelength. I mean, if frequency and speed is same, then wavelength would automatically be same. Then traveling in opposite direction. The two waves must be traveling in the opposite direction, for example, the incident wave and the reflected wave. And lastly, the waves should be meeting at a point. So you can write all of it in description. These 4 pointers should be of the same nature. They must be having same frequency, wavelength, or speed, and they must be traveling in the opposite direction, and the waves should meet at a common point. State what it meant by node. Calculate the wavelength of two waves forming the stationary waves. Stationary wave. We must be given with the diagram here. Okay, we do have the description. The distance between a node and the adjacent antinode is 6 centimeters. Now that's a very good thing, that we are provided with the distance between the node and the adjacent antinode, means consecutive node and antinode. So the graph is probably, let's assume this one is the wave, stationary wave, and I can show that this wave is oscillating up and down by drawing a dotted wave also. So this is a stationary wave, and what we are given with is the distance between adjacent node and antinode. Let's say this is the node and the next one is the antinode. So node is once again the point where the displacement is 0. Antinode is the point where the displacement is maximum. So in terms of the wavelength, the question is, in terms of the wavelength, the distance between node and antinode is how many times the wavelength? Is it half times the wavelength? Is it 1/4 times the wavelength? Or is it actually equal to the to the wavelength? Okay, we need to calculate in, by the way, we need to calculate in centimeters. So I need to convert the units. It is 1/4 the. So 6 centimeters, it's not half the wavelength. It's not the wavelength, it's quarter of the wavelength. Because for the wavelength, we have to go from here back to the node, go to the next antinode, all the way to the node. In one complete wave, we have 3 nodes and 1 antinode. So this would have been one wave uh, till here. So the given distance is only quarter of the wavelength. Hence wavelength has to be 4 times of 6, which is 24 centimeters. State the phase difference. You see, for stationary waves, they ask you about the phase difference with the command word state, because the answer has to be either 0 or 180 degree. There is no third answer. Probably there is a third answer, which is known as the wrong answer. So either the answer has to be 0 or 180. State the phase difference between particles at two adjacent antinodes of the stationary wave. Yes, anyone who can tell me the phase difference in this case? Between two adjacent nodes mean between two consecutive antinodes. This is what we mean by between two adjacent antinodes. So what does that mean? Because let's say this is the node 1, this is the node 2. All the particles which are between these two nodes would be having the phase difference 0. Have the part C, a stationary wave is formed on a different string that is stretched between the two fixed points x and y. So this is the stationary wave produced in the first case where you have both ends closed. State what is meant by the node of the stationary wave. Okay, forget this one. Node is a point where the displacement of the particle is 0. In this diagram, I can see 3 nodes, 1, 2, 3, and I can see 2 antinodes. One of them is labeled as W, the other one is labeled as that is not even labeled. State the number of antinodes 2. State the phase difference between points W and Z on the string. Okay, the points W and Z, they are separated by a node, or should I say they are separated by odd number of nodes. Hence the phase difference would be 180. And we know that W would move downward, but at the same time Z would move upward. So the phase difference would be 180. Now a new stationary wave is formed on the string. The wave has the frequency that is half of the original. So frequency is half of the original, the speed remains unchanged, and we need to draw the new wave. So frequency is half, which means if speed is same, you see, frequency is reduced to half, speed is same, then the wavelength has to be doubled. Otherwise, your speed cannot be same. So if one thing is being reduced to half, the other thing must be doubled only to make frequency speed constant, because the formula is V equals to F lambda. And the thing is, they are saying they have doubled the double the frequency or half the frequency? Yeah, they have lowered the frequency to half. This one is decreased by 2. Now the other thing has to be increased by 2, only then the value of speed can be kept constant. For example, let's say the frequency were 10, wavelength were 2. Now you have reduced the frequency to half. Now frequency is 5. The other thing has to be 4, only then the speed can be same, which is 20 in this case. So the wavelength has to be doubled. Now we'll be getting a 2 times longer wave, and hence you see in this part we are having one complete wave cycle from x to y. But if I double the wavelength from x to y, I'll be getting only half the wave cycle because the wave is now longer. And if you guys could remember, when we have the two fixed points or the closed ends, this kind of wave is the lowest frequency that you can have. This is known as first harmonic, aka fundamental harmonic. And the one that was given initially, for that case when the two ends are closed, this kind of harmonic is known as the second harmonic.